My name is Ali Jamil. We are in the Laboratory of Allergic Disease in Building 10 at the National Institute of Health in Bethesda, Maryland. So currently, at the moment, I'm working with a cohort of patients who have an undiagnosed allergic disease, and we're trying to figure out what it is. They present with a similar phenotypic expression as Job syndrome, which is a genetic allergic disease where patients have recurrent rashes, recurrent infections, and connective tissue disorders. However, the cohort of patients of ours that present in this way don't have the genetic mutations that are characteristic of Job syndrome. And so, in addition to that, also in the cohort are patients that have all types of variable expressions, and we're trying to figure out what if a common mutation exists amongst all of them. So I was born and raised in Poughkeepsie, New York, which is about an hour north of Manhattan, maybe 2 hours according to some people, depending on how bad traffic is. And I went to undergrad at Vassar College, which is also in my hometown in Poughkeepsie, New York. And I'm currently between my third and fourth year of medical school at New York University, NYU in Manhattan. So I think what I do is inspiring because it helps the society as a whole, not just the United States of America, but the whole world. Being able to just obtain knowledge and use that to cure patients is probably the most inspiring thing about this job. So here we're analyzing patients' serum for DEC205 mutation, and here we go. This is a flow cytometer that was washed, and now we're putting in the sample. So that's the one side of my project is clinical. The other side is translational, where I'm using flow cytometry and real-time PCR to detect novel mutations in patients' blood samples to see what mutations they have. And so there's pretty much a big mixture of antibodies that the T cells are being mixed with, and the fluorescence, the intensity of the fluorescence tells us several different things about how the T cells are interacting and what cells it's producing and the things that are influenced by it. I think just knowing that I can be a part of helping patients with a debilitating disease for which there's no cure now, but by discovering new aspects of the disease on the genetic side and knowing that this can possibly lead to new therapies in the future is what gets me up in the morning. And knowing that I'm sort of part of this machine that is sort of operating for the sake of society, and knowing that the purpose is really pure and for the sake of helping people, I think is what keeps me going at it.